giving you a video that shows the types of problems that will be on the test. These are problems that I pulled from the test. I'm going to change the numbers to make all these things work. So right now I've given you everything that we see. A skateboarder starts from rest and maintains constant forward acceleration of 0.5 meters a second squared for 8 4/10 seconds. What's the rider's displacement during this time? So I made my list. I'm looking for displacement. I've been given acceleration. I've been given time. Okay. When I write this out, here's the formula: x equals 1/2 at squared. So I'll just start putting numbers in. X. Oh, Harry. Here we go. Sorry. There we go. X equals 1/2 times 0.5 meters a second squared, right, times 8.4 seconds, and square that. And so these seconds squared are going to cancel out with these seconds squared when we do all that math. I did the math on my calculator before I started this, so I know I'm going to be done in meters. I know that my answer is just about, oh, sorry, my little squiggly equal sign. There we go. Is just about 17 64/100 meters. And don't forget, we're going to make sure we use parentheses and stuff like that on our tests. All right, the next question. What is the acceleration of a car? The sports car goes 100 meters forward in the first 4.5 seconds of constant acceleration. And if you look at this, I have just taken this formula, right? This formula right here, and solved it for acceleration, which means I multiplied by 2 to get rid of the half. And then I divided by t squared, and that is a equals 2x over t squared. So now all I have to do is say, well, x is 100 meters. And the time in question is 4.5 seconds. And so when I did that work, I'm almost positive that when I did that, I had A equals 200 divided by 4.5 seconds. So it's 200 meters, 4.5 seconds squared. And what that gave me was a number just about 9 88/100 meters a second squared. All right, so that's how we did that one. I'm surprised they didn't write out the list of what we were given. Everything else I wrote out with the list was what we were given. All right, so a rolling ball has an initial velocity of 1 6/10 meters a second. If the ball has constant acceleration of 33/100 meters a second squared in the same direction as its movement, it's speeding up. What is its speed after 3.6 seconds? So here's the formula: VF equals VI plus AT, everything we've been given. So I'll start putting that stuff into the formula. So V final equals V initial, which is 1.6 meters a second, times 3.6 seconds. And we notice that the seconds on top cancels out with seconds on the bottom. We end up with meters plus AT, which is 0.33 or 3300 meters a second squared. And we're going to multiply that by our 3 6/10 seconds. Oops. I made a mistake. Don't do that. It's just VI plus AT. I don't want to start this video again. I don't have enough time. So here's the formula. I apologize for writing this in. That comes in downstairs, down below. All right. 1.6 meters a second plus AT, VI plus AT. 33 hundredths meters a second squared times 3.6 seconds. 1 second will cancel out the square here. Now we're in meters a second. So my final velocity, oh my God, I'm so sorry, is about, none of these are right on the money. So this is about 2 and 79/100ths meters a second. Sorry about that last one. Here's the VIT piece. How far did it travel? All right, this is where we're going to put in the time. I apologize for that earlier. So here we go. We've been given a time of 3.6 seconds and an initial velocity of 1.6 meters a second. 1.6 meters a second times the time. Here we go. This is where it was supposed to go. 3.6 seconds. And seconds cancels out with seconds. And then we get a number in a value in meters. Then we have 1/2 times the acceleration is 33/100ths meters a second squared times 3 6/10 seconds, and that whole thing is squared. So second squared cancels out with second squared. We'll have meters. When I do all that math, we have traveled just about 6 and 82/100ths meters. 6 and 82/100ths meters. Okay. There we go. And now let's move on to the last set. This is the last set. This is the squirrel problem we talked about earlier today. Last but not least, time in the air. The squirrel drops an acorn from a tree branch that's 8 meters from the ground. How long is the acorn in the air? Well, okay, T equals the square root of 2 times the height divided by gravity. So here we go. Two times 8 is 16. And gravity is 9.8 meters a second squared. So meters will cancel with meters. And what we come up with is just about 1 and 28/100ths seconds. And so I'm going to take this value and I'm going to put it down here. Okay, so 1.28 seconds. And now I can do this problem here. What is the acorn's speed just before it reaches the ground? Well, it's VF equals AT, because there's no initial velocity in this problem. It starts from rest, and then the squirrel drops the acorn, and then it speeds up as it heads toward the ground. So VF equals A, which is 9 8/10 meters a second squared, times 1.28 seconds. I'm going to check this out. I think I did this right. Yeah, I did. Okay, so it's going just about 12. V final is just about 12. Sorry, this second cancels out with one of those, by the way. 12 and 54/100ths meters a second. Sorry, I got sidetracked there for a second. That's it. We have finished the video. So I'm going to post this video in its raw form, and then I'm going to also upload it to YouTube if you can't access an MOV file. All right, so thank you very much. Bye-bye.